Hi friends, this is a question of November 2008. The question is very interesting and let's start. First is the differential equation has been given and we are supposed to prove that y is equal to tan inverse 1 plus sine x when y is equal to pi by 4 and x is equal to pi. The differential equation we have to use this dy by dx upon cos x equal to cos x cos square y. Then comes b part, which is one of the most important point. So now dy by dx is given cos x cos square y. We will bring cos square below dy by dy and we will take dx to the side. So dx cos x dx. Now we will integrate both sides. Cos square x will become sec square y over here. Cos square y will become sec square y. Now this is nothing, so nothing to be confused about. So integral of sec square y will give us tan y. Integral of cos x sin x plus c. Y is equal to pi by 4, which was given in the question, and x is equal to pi. We will substitute in the equation and we will get the value of c as 1. From equation 1, that is this, we can say now that tan y is equal to sin x plus c, which we can say y equal to tan inverse sin x plus 1, or y equal to tan inverse 1 plus sin x, which is proved. Or we can say tan y is equal to 1 plus sin x. Why I have written this because this particular equation we would be using in part B. Okay, now part B. Part B says the limit tan inverse 1 plus sin x minus a upon x minus pi by 2 whole square. They are saying to find the value of a. So in this, if we put in this equation, if we put x equal to pi by 2, the denominator will become 0, therefore the function will go undefined. So therefore we will have to make this function into indeterminate form. This is what I have done. Limit do not exist at x equal to pi by 2, as the function will be undefined at x equal to pi by 2. Therefore we will make it into indeterminate form of the form 0 by 0, and for that value of a should be equal to tan inverse sine x plus 1 or 1 plus sine x. The moment we will put over here, this will give me 0 in the numerator and 0 in the denominator when we will substitute pi by 2 in this equation. Hence that equation will be of 0 by 0 and which will be used for L'Hopital rule further. Now the same part B continue. We are given with y equal to tan inverse 1 plus sin x. I differentiated this equation to this part, to which I can say y dash equal to this cos x upon 1 plus bracket 1 plus sin x whole square, because the differentiation of tan inverse of x is 1 plus 1 upon 1 plus x square. So this is 1 upon 1 plus x square. This is whole of x, you can say. Okay, and when we differentiated 1 plus sin x, we got cos x. So this is the thing we got. Now y dash is equal to cos x upon 1 plus bracket 1 plus sin x whole square. Now we further differentiated this into y double dash, because if we put this into the final equation and put pi by 2, so cos x will give me again 0, so numerator will be again 0, and in the denominator we have pi by x minus pi by 2, so this part will again become 0. So to solve this further, I differentiated this part using quotient rule, and this is the solution that we have got through the quotient rule. Now the catch point in this is 1 plus sine whole square. To this I can write it as tan square y. So to tan square y, I can write it as sine square upon cos square y. 1 is over here, so cos square will be taken as LCM and we will use cos square y over here. This will give me cos square y plus sine square y equal to, which is 1 upon cos square y, minus over here the cos x it will be, and this will give me, this 1 plus sin x will give me tan y, to which I can write it as sin y upon cos y, sin y upon cos y into cos x. This is the cos x. In the denominator as well, 1 plus sin x whole square, 1 plus, I can write this as 1 plus tan square y and whole square. Now to this I can write it as sine minus sine x upon cos square y, and this as 2 cos x sin y cos x upon cos y, taking LCM as cos square y, which I have taken over here, cos square y. This should be cos square y. This is the thing. And to 1 plus tan square y, I have written as sec square y to the power 2, which will give me sec to the power 4y. I repeat, to the denominator 1 plus tan square y, we can write it as sec square y. It is whole square, so it is sec to the power 4. Now I have divided, actually I've converted this cos sec square to the power 4 into cos, and I have taken this cos to the power 4 in the numerator, and I solved this whole along, which you can follow gradually. Everything has been done very clearly, and accordingly this cos square y I have added over here, multiplied over here, and I multiplied over here, and the rest cos square y will cancel out this cos square y. So now I wrote this in the next line, cos square y as 1 upon sec square y. To this sec square y I can write as 1 plus tan square y. To this tan square y I can write it as cos 1 plus sin x whole square. Rest of the equation is same. This part is your y dash of x that we have done in the past. Y dash of x. Y dash of x is, this is cos x upon 1 plus sin x. Now I have taken this in the whole system as LCM, and I multiplied this over here. So this gave me sin x cos square y 1 plus sin x whole square minus 2 cos x cos y sin y cos x upon this. Nothing to panic about, because we have to move gradually. If you will move fast, you will definitely make a mistake, because this is a very good question. Now substituting the value x as pi by 2, because we had the limit pi by 2, cos square y will become 1 by 5. So at pi by 2, sin pi by 2, 1, that's minus 1, cos square y 1 by 5, this complete 1 bracket 1 plus sin whole square will give you 5 cancel out. Over here this will be 0, because cos pi by 2 is 0, so this whole equation will be 0. So this is 0 upon 1 plus sin whole square. So putting pi by 2 in sin x, this will give me 1. So 1 plus 1 2 square is 4 plus 1 is 5, so 5. So your solution is the value of y double dash is minus 1 by 5. Now y double dash is equal to minus 1 by 5 at x equal to pi by 2. Hence required limit as at x pi by 2 is y dash upon 2 is equal to minus, this is actually y dash upon 2 So this is actually minus 1 by 5 upon 2, which will give me minus 1 upon 10, which is your answer. Now the theory part, how cos square y became 1 upon 5. We had y equal to tan inverse 1 plus sin x, tan y is equal to 1 plus sin x. Putting pi by 2 in x, we get this is pi by 2. This is actually pi, it's my mistake, mistakes do happen. So x equal to pi by 2. So the moment we will put pi by 2, we will get tan y, this is tan y, so tan y is equal to 2. Making a triangle, to understand, tan is equal to perpendicular upon base. So I have taken angle as theta instead of y, so this is perpendicular to, this is 1, so tan theta is 2, so cos y will be, hypotenuse over here is root 5, so cos y will be 1 upon root 5, hence cos square y will be 1 upon 5. Apply in the question and you will get the answer. Thank you very much, hope you have enjoyed the channel. Thank you very much.